This mysterious thing really started a year ago in Kutna when we were sitting together with some people at the table, Johan, Sis, I remember, Antonio saying, what are these strange long-time reflections? Is this now solved or not? So I looked a bit into that again, because indeed, you see, I looked in that before. This is not a mistake. It says CDU 2011. So this is a repeat, but it's universal knowledge. And thanks to the previous speakers, I can skip already a lot of that. A typical spectrogram, you've seen that. What do you see? If you're close enough, you have the carrier, direct reception, and you have many or several underdense reflections. This is during February, so it's not a particular busy month. Time scale 5 minutes, very typical band range, 200 Hertz on a 50 low volume, low power beacon. But you can, what you see, that I said, the carrier, the underdense meteors. But now we come. This is June, and in June you have very strong daytime streams, and there you see other things. You see these curly things, and that's what somebody called epsilons. I don't know who, but it's pretty obvious that you can call it like that. You have, of course, also the planes. A plane is this one. A meteor is really the same thing, but much steeper, of course. We have seen that too, very steep, right? So it's about these long-term reflections that we want to talk. We observe these things, typical one, from several places around the beacon. And then I have the beacon 20 kilometers to the left, right, all around. And basically you see that the same shape appears everywhere. And that must mean something. In my opinion, it means that you have some symmetry around the vertical axis and that you go around and you see still the same thing. Right? Okay, so that. Now you can have also, you can view that also on 2 frequencies. Here they are the both beacons, you basically have the same shape. So it's not a kind of an artifact. The time resolution is okay, frequency resolution is there. It happens on all frequencies. This is something real, let's say, and repeatable. And even on the frequency of grav of the radar, you have that also. It's much stronger and it lasts much more. So that's coincide. And by the way, you can have also some small epsilons, like call it, short in time. These are not always to be wrong. So that is still the same phenomena. Back in 2005, a professional guy, Bourdillon, still wrote something about that. This is again Doppler. He wrote about that. But why are these fragmented tails? So you see several tails, trails so long. And it has remained a mystery for a long time. That's why I use the term mystery. It's not my term. All right, let's try to see if we can reproduce that and use a simulator for that, a ray tracer. If you have just a cylinder, like a specular reflection, you have some reflection points, of course, and that's where it is, very simple. And only, we know that only a part, the reflective point contributes. That's all said already. I found another one in this reference where he says this is for the evolution of a trail. So there indeed you see something expanding horizontally at that altitude. That corresponds to what I said, that you have some circular thing that expands all the time. Now, with that alone, you don't get there. On a convex surface or body, you can have only one reflection point. That's up here and there. But on something hollow, you can have more, of course. You can have like a focusing effect. And that's here, I did that with the ray tracing. On a donut, you would have 4. And if you let that, a torus, you let that evolve, and sorry, this is going wrong. You have this animation is not running, but you can see these four things evolving. I'm retracting that one. That torus thing is definitely not the right one to do, but because we need other things. So what did I knew? I looked through the literature. You can have follow archive the abstracts. It's not much in there, and the physics one, I would not be able to follow all of that. So I asked my friendly large language model to give me some help. I did not ask solve me the mystery because I was afraid of things written under the influence of LSD. But asked for references. I said what I knew, field-aligned irregularities, head decals, all of that. And it suggested me search like Google Scholar, Web of Science, shows that. In the end, I went on with academia and I got my list of publications. Here they are. This is by no means complete because I searched manually and it suggested something else. These are the things I found. Here you see the years. These are not the journals we normally, these ones, that's not geophysical things in our astronomy community. We don't use that often, but that's where it's found. The name that jumps out of this here, Johan is there too, is Lars Dieret. Has a few good ones. And I learned 2 days ago, Lars Dieret was the first PhD student from Meers Oppenheim. So we are in good company. Right. What it's all about is if you have in a plasma some instability, this is coming from Wikipedia, then that starts with injection of a particle, let's say a meteor. Then you have a two-phase instability and you have different things. Because here it says you start out with an ablation phase, you go to the plasma, and then you have these kind of reflections. And this is a kind of surface that interests me much because it's a convex surface. And with that one, probably we can have the next step. All right, he says that. There's an analogy that's also not mine, so it's really psychedelic by now. There's a lava lamp, which is also a two-phase instability, which you can have, of course, all kinds of very interesting reflections. What I did not discuss, it was discussed in the workshop, are the non-specular trails. What we see is there, it is something coherent, so it is, after all, specular, but the meteor is a long time gone, and the meteor lasts a couple of tenths of a second. This is going on for much longer. This one we see too, this is all the noise. This is spread out in space and also chaotic in frequency, so we have a big spread in frequencies. Is now this thing solved? Not really. I also did not say that in the title. It's solving, but I think that now we have some good inspiration for going on with that. And if there are other interests, more recent references, of course, I might find now after the workshop and having the right people in the place. Thank you for the first one.
Thank you, Chris. I think this can bring us closer to solving the riddles. So I hope some people in the room are intrigued by that. Are there any questions here? I see no questions, I believe.
Hold on a second.
Sorry?
That was me.
Okay.
Oh, Regina.
Regina over there. Okay.
Intrigued by the hallucinations, I was wondering how many of those papers, except those two that you focus on, were really made up? Because this is what I come across when sometimes I ask something, and then it's like, so that, okay, but I'm looking for example, Borovichka. It literally made up, just putting the name of Borovichka at all, yeah? So I was wondering how many of them actually were, not legit ones at this point.
I think there are. Being a dinosaur, I printed them all out.
That's good. Are there any other questions? Online questions, perhaps? Hervé? Yeah, sure.
Yep.
We have time for a last question here, and then we go to the next speaker, which is again Chris.
Thanks, Chris, for the nice talk. So in the example you showed, you showed that all the stations are seeing
some circle thing. Yeah.
But what I see also from time to time is that the let's say the spectral width between the different branches varies from station to stations. So that's also something interesting.
That's very interesting, of course, because the difference in frequencies of these two branches means a difference in projection of the speed. And that's possible, of course, because you are at a lower angle. That's excellent. With these ones, these are old, but I'm very interested with the multi-stations that this can be checked or proven, and we get a step